In ancient times, when science was in its infancy, people perceived the earth differently. Influential figures like Pythagoras, with nothing but their naked eyes and curiosity, observed the heavens and celestial structures. Despite the lack of knowledge, they were drawn to space, sparking the birth of astronomy in regions like Egypt, Babylon, Greece, Mesopotamia, and India. As our ancestors began to sail around the world, navigation became vital. Before the invention of the compass, sailors used the stars for navigation. Constellations like Orion, which rises in the east and sets in the west, served as reliable guides. Time, an essential component of our universe, was measured differently over 32,000 years ago. Sundials were used, and people noticed the varying lengths of days throughout the year. In Malaysia, Islamic astronomy played a crucial role in the observation of the crescent or hilal to determine the start of Islamic calendar months, such as Ramadan, Syawal, and Zulhijjah. As astronomy evolved, it significantly impacted the development of communication and astronautics. The creation of antennas, infrared radiation, and radio waves, initially for military and astronautics, later influenced the development of the Internet, GPS, and other technologies that enable global communication. Astronomy also intertwines with various other sciences. To understand the universe, astronomy requires tools developed in electrical engineering, chemistry, optical science, physics, computer science, and biology. Simulation technology, for instance, is crucial for modeling cosmic events and predicting potential threats like asteroid or meteorite collisions. Astrobiology, the study of life on other planets, holds the promise of future human colonies on Mars. Studying astronomy opens doors to numerous other disciplines, such as astrobiology, astrophysics, galactic astronomy, and planetary science. The opportunity to study this remarkable subject offers a gateway to understanding the universe and our place within it. In summary, astronomy, from its humble beginnings with stargazers and ancient sailors, has evolved into a complex science that intersects with various other disciplines. It has shaped our understanding of time, navigation, communication, and even life beyond Earth. As we continue to explore the universe, who knows what astronomical discoveries await us in the future?
Have you ever wondered how astronomy affects your daily life? It might seem like a distant science, but the reality is, it has shaped our world in countless ways. From the dawn of civilization, the stars have guided us. Ancient humans named the constellations and tracked their movements to know when to sow their seeds. Astrologers kept a vigilant eye on the heavens, looking for any changes that might predict impending doom. For the everyday person, the stars served as a tapestry of tales, immortalizing beloved legends and stories. Fast forward thousands of years, and astronomy's influence on society has only grown. The digital camera in your DSLR and smartphone, they owe their existence to the tireless work of astronomers. Wi-Fi, that ubiquitous technology we can't live without, was conceived by an astronomer trying to improve his telescope images. Even our understanding of Earth's future has been shaped by astronomers observing Venus's runaway greenhouse effect, giving us crucial insights into our own climate change. For over 2 decades, a 400-foot Y-shaped astronomical observatory has stretched across Anderson Mesa in northern Arizona. This colossal instrument, operated by the U.S. Naval Observatory and Lowell Observatory, catalogs the precise locations of stars and tracks their minute movements. GPS satellites and other spacecraft rely on these star charts to navigate through the cosmos. Without them, GPS wouldn't be able to guide us, and modern technology, including your cell phone, would be lost, and quite possibly so would you. In many parts of the world, astronomy is literally keeping the lights on. In the 1930s, the German-American astronomer Hans Bethe discovered that nuclear reactions power our sun and all other stars. His work explained how the sun uses nuclear fusion to turn hydrogen into helium, releasing massive amounts of energy. This revelation quickly found applications beyond astronomy, particularly in the development of nuclear power plants, which now number in the hundreds worldwide. Around the same time Bethe was deciphering the secrets of the sun, Scientists were developing the first radar instruments to study Earth's ionosphere. When Britain grew anxious about potential German air raids, they turned to radiophysicist Robert Watson Watt. Instead of creating a death ray to down enemy planes, he suggested using radar to track them. As World War II broke out, radar technology became an indispensable tool in the arsenal of defense. In conclusion, astronomy has had an immeasurable impact on our daily lives. From the technology we use to the energy that powers our homes, and even to our understanding of the world. So the next time you look up at the stars, remember their influence extends far beyond their celestial sphere, right into the core of our modern world.
Have you ever wondered how the mysteries of the cosmos might lend a hand in unraveling the enigmas of the human body? It might seem far-fetched, but the connection between astronomy and medicine is more profound than one might initially perceive. In the grand tapestry of human knowledge, the threads of astronomy and medicine have often entwined, each influencing and enhancing the other throughout history. In our quest to understand the universe, we have developed technologies and techniques that have simultaneously propelled medical science forward. Perhaps one of the most notable instances of this interplay is the technique of aperture synthesis, a brainchild of the radio astronomer and Nobel laureate Martin Ryle. This technology, initially used to gaze at distant celestial bodies, now forms the backbone of medical imaging tools such as computerized tomography, magnetic resonance imaging, and positron emission tomography, to name a few. Astronomy has also gifted medicine with programming languages like IDL and IRAF, simplifying the intricate task of image processing. Consider the clean, dust-free environment necessary for crafting space-based telescopes. The protocols, air filters, and bunny suits developed for this purpose have found their way into hospitals and pharmaceutical labs, ensuring sterile conditions for medical procedures and drug manufacture. Astronomical tools have even found direct applications in medicine. Blood samples from leukemia patients can now be analyzed faster and more accurately, thanks to a collaboration between a drug company and the Cambridge Automatic Plate Measuring Facility. Methods developed by radio astronomers are now being used to detect tumors non-invasively, boasting a staggering true positive detection rate of 96% in breast cancer patients. The list goes on, from thermal sensors initially designed for telescopes now controlling heating in neonatology units, to software for processing satellite images being used to screen for Alzheimer's disease. The same adaptive optics used in astronomy for observing celestial bodies through the turbulent atmosphere are now used for retinal imaging, allowing researchers to study diseases like macular degeneration and retinitis pigmentosa in their early stages. In summary, the relationship between astronomy and medicine is a testament to the interconnectedness of human knowledge. The tools and techniques developed for observing the cosmos have been instrumental in advancing our understanding of the human body. From imaging technologies to cleanroom protocols, from programming languages to direct applications of astronomical tools, the influence of astronomy on medicine is profound and far-reaching. As we continue our exploration of the universe, we can be certain that the insights we gain will continue to shape and enhance not only our understanding of the cosmos, but also our ability to diagnose, treat, and ultimately conquer the diseases that afflict us. The International Astronomical Union's strategic plan for 2010-2020, with its focus on technology and skills, science and research, and culture and society, is a testament to this enduring symbiosis. And so, as we gaze into the stars, we also gaze into the future of medicine.
Have you ever considered the profound connection between the celestial bodies we gaze upon in the night sky and the everyday technologies we find indispensable? It might surprise you to learn that the field of astronomy has been a significant catalyst for technological breakthroughs within various industries. The journey begins with the creation of a film known as Kodak Technical Pan in the mid-20th century. Initially developed to help solar astronomers record the dynamic changes in the sun's surface structure, this film found its place in medical and industrial spectroscopy, industrial photography, and even the world of art. It was also instrumental in detecting diseased crops and forests, assisting in dentistry and medical diagnosis, and even revealing forgeries in layers of paintings. Moving forward to the 1970s, a significant development emerged that would revolutionize the way we capture images. Willard S. Boyle and George E. Smith were awarded the Nobel Prize in Physics in 2009 for the development of the charge-coupled devices, or CCDs. These devices, first used in astronomy in 1976, quickly replaced film in telescopes, personal cameras, webcams, and mobile phones. The advancement and widespread use of CCDs can be attributed to NASA's decision to implement this super-sensitive technology on the Hubble Space Telescope. In the realm of communication, radio astronomy has been a fertile ground for technological innovation. Many successful communications companies today were initially founded by radio astronomers. A prime example is the computer language Forth, originally developed for the Kitt Peak 36-foot telescope. Today, it forms the backbone of FedEx's worldwide tracking services. The influence of astronomy even extends to the automotive industry. For instance, General Motors utilizes the astronomy programming language, Interactive Data Language, or IDL, to analyze data from car crashes. The first patents for techniques to detect gravitational radiation, a product of massive bodies accelerating, were obtained by a company to ascertain the gravitational stability of underground oil reservoirs. Transitioning from ground to the sky, the aerospace industry shares a significant amount of its technology with astronomy. Defense satellites, which are essentially telescopes pointed towards Earth, require identical technology and hardware to their astronomical counterparts. The processing of satellite images also relies on the same software and processes as astronomical images. To sum up, the field of astronomy has been a silent yet persistent force, driving technological advancements across various industries. From imaging and communication to the automotive and aerospace sectors, the influence of this science is far-reaching and profound. Whether it's through the development of advanced imaging technologies or the creation of computer languages, astronomy continues to push the boundaries of what's possible, and in doing so, shapes the world we live in today.